Hi, good morning to everybody. I am Dr. S. Dhanambal, Associate Professor in CSE Department, belongs to Kogunadu College of Engineering and Technology, Tottiyam, Trichy. Today I am going to explain the concept under the subject name is Artificial Intelligence in Unit 2. The topic name is gaming. It's a very interesting topic under the artificial intelligence. First, I'm going to give you a small introduction about the game. What do you mean by game? They are going to implement the concept under the artificial intelligence. These are the important topics we are discussing in today's session. First, we will discuss about the introduction part about the gaming. What is a game? A sort of conflict in which an individual or group participate, mathematical framework, decision making, intelligence. Okay, these are the important role of the gaming. A sort of conflict in which an individual or group participate. A game is they are going to participate the individual person, otherwise group of people are together to play the particular software. It's called as a game. A mathematical framework, just to construct a game based on the mathematical framework. A decision making based on the decision making based on the decision they're going to execute the particular sequence is called as the decision making. Intelligence based on the intelligent activity they're going to execute the one particular sequence. It's called as the important role of the game. Application of game theory. Then we did discuss about the important applications under the game theory in artificial intelligence subject. One is the economic model, social science, and another one is the military strategies. These are the important applications of using under the game theory. A definition of game. The game has at least two players. The soldiers is not considered a game by game theory. The term soldiers is used for single player game of concentrations. The definition of game have at least two players. Sometimes maybe in real time world, you have a lot of games playing. Minimum of two players is possible to play the particular any one game. In computer based, the computer is one player, then person human is another one player. They're playing the game. It's called as a minimum of at least of two players. It's considered as a two human players. Otherwise, one system and another one is a human. It's considered as a playing game. Then what kind of games? Mainly games of strategy with the following characteristics. These are the important. Sorry. These are the important characteristics of games. One is the sequence of moves to play, rules that specify possible moves, rules that specify a payment for each move. Objective is to maximize your payment. These are the important characteristics of the games. One is the sequence of moves to play. Sequence of means, suppose you are going to construct the or create a one game software. Under the game software, the sequence of sequence is used to create a game that based on the sequence execute the particular software. It's called as a game. It's a moves to the play. It's a sequence of moves to play. Rules that specify possible moves. Rules, if you are traveling in the right side, means just you have a right side sequence, the one by one sequence, finally you are going to reach a destination. Suppose take a simple example, you are traveling from a route node to the right position, otherwise left position, based on the sequence, one by one sequence, finally you are going to reach the destination. Is the rules based on the moves. Rules that specify a payment for each move. Sometimes you have a just sequence one, you are reached, means just you are completed, then move to the sequence two, and one by one is the finally you can reach the destination. So maximize of the payment. Then games versus such problems. Unpredictable opponent, specify moves for every possible opponent to play. It's the unpredictable game. Is the unpredictable opponent. Okay, we are not know what they are doing in the opponent party. Everything is not possible to know on the current situation. It's called as an unpredictable opponent. Specifying a move for every possible opponent you play. Time limit is that you have a particular time period only you have completed the particular task, then only possible to move the one task to another one task. Suppose the particular time period if you are not completed the particular sequence, means it's not possible to travel the one sequence to any another one sequence in the game. So it's a very important time limit. Unlikely to find a goal, must approximate. It's a two-player game. Take a simple diagram, flow diagram for the two players game. One is opponent move, generate the new positions. If the game over, yes means just completed the task. Otherwise, game over no means just move to the generate successor. Success may create a successor, evaluate the successor. Based on the evaluated successor, then move to the highest value. Move to the one sequence to another one sequence. If the one moved one sequence to another one sequence, suppose you have a 10 sequence to finish the particular game, means the first one is the generate the successor, evaluate the successor, then move to the highest value successor. If the level, if you are playing in the level 1 means it's a sequence 1, move to the sequence 2. Okay, it's a one by one move to the sequence 2, sequence 3, sequence 3. Finally, you are going to reach the sequence 10 means it's a game over. Yes, because you have a final level is a sequence 10. If you are completed means yes means automatically exit the game. You are win the game. Okay, otherwise on the game, otherwise it's move to the no. If you have traveled to the next sequence, then create a successor based on the generated successor, just move to the level by level. It's called as a game playing scheme to play game. Then types of game, based on the types of game, we have a different types of games. Then based on the chance, deterministic, not involving chance. It's a deterministic, non-deterministic. Two important types of based on the chance. One is a deterministic, means not involving chance. Chess, checker, tic-tac-toe. These are some other important deterministic game examples. In non-deterministic game example can involve the chance. If the opponent party also, it's possible to involve the game in the particular time period. It's a Bogman, a Monopoly. These are the some other important examples of non-deterministic gaming software. Okay, based on the information, perfect information. Here all the moves of all players know to everyone. Okay, here you have a that's a chess. You are playing the chess means all the moves. Every moves with the no opponent party. It's called as the deterministic type. Okay, all the moves of all players knows to everyone. It's called take a simple example chess. If you are move the one position to any another position, all the persons know which position you are moved from a previous position to new positions. Is called as a take a simple example. Imperfect information. Here all the moves not know everyone. It's a take a simple example. Bridge, poker is another simple example game. In this game, the opponent party is not know what are the moves are used in the opponent party. It's called to take a simple bridge. Poker is a simple example of the unknown move games. Game theory does not prescribe a way or say how to play a game. It's set of ideas and techniques for analyzing conflict situation between two or more parties. The outcome are determined by their decision. Okay, just is an important role. Game theory does not prescribe a way of say how to play the game. It's not prescribe the how to play the game. Based on the current percept action, you are going to play the game. If the percept action, you have a take a simple example. If you have a two sequence, based on the percept action, you move to the sequence 1, otherwise sequence 2. It's a set of ideas and techniques. It's based on the set of ideas and techniques used to execute the particular sequence. The outcome are determined by the decision. So decision, based on the sequence, they're going to execute the particular operations. A gentle game theorem, game rules, perfect information, strategies, move, and outcome payoff. These are the important game theorem. Okay, game tree, 2 players deterministic turns. Computed turn, you have a maximum, minimum, maximum, minimum, maximum, minimum. Is a starting position, is a game started in this position. Whether you have a minimum game 1, 2, 3, 4, 5, 6, 11, 7. These are the different types of sequence. Whether if you can travel to the in this sequence, minimum in this sequence mean if you have traveled in this sequence mean in this sequence you have a 3 important sequence. One is the left side, another one is a mid side, and another one is a right side. Whether you are traveling in the left side means just in left side you have a 3 travels. It's a continue up to end of the game. Okay. Whether if you are traveled in the 1 by 1 sequence, finally you can go to reach the destination means automatically you are succeed the game or you are won the game. Okay. You are winner the game. Take a simple computer turn, opponent turn, computer turn, opponent turn. Leaf nodes are evaluated. Finally, you are going to reach the set terminal. It's the end mode. End mode is based on the end. You can identify whether you are won the win, you are winner in the game. Otherwise, you are lost in the game. At the leaf node, the utility function is employed. Big value means good, small is bad. Whether you have a 0 means a good, otherwise plus 1 means good, 0 means okay, minus 1 means bad. This is based on the big value. Whether if you are winner means you are received the plus 1. Whether you are a second position means you are received a 0. You are a loser means just received the minus 1. Is the game tree two-player deterministic and terms. And then above is a partial tree for the game of tic-tac-toe. The top node is the initial state. It's called as the initial state. Based on the initial state, you can you can travel to the one by one all the sequence. Finally, you are going to reach the final leaf node. Is the final node. Okay. In this final node, you are received the plus 1, 0 or minus 1. Plus 1 is the higher level, minus 1 is the lower level. Just here mentioned, the top node is the initial state and the maximum move first, placing X in an empty square. The rest of the search tree shows alternative moves for minimum and the maximum. Terminal states are the assigned utility according to the rules of the game. Minimax terminology. Utility function. This utility function is one type of functionality. In this functionality, used to create a game under the two important positions. One is the maximum position, otherwise the minimum position. The function applied to the leaf node backed up value, you have maximum position or minimum position. The maximum position, the value of the largest successor. The minimum position, the value is the smallest successor. Here you have and this take a simple example, is the maximum successor, is the minimum successor. Maximum successor, you are received the plus 1, the minimum successor, you are received the minus 1. Minimax procedure, search down several levels. At the bottom level, apply the utility function, backup values all the way up to the root node and that node select to the move. Minimax, just to take a simple example, I am going to explain the Minimax methodology. Okay, perfect play of deterministic games. Idea: choose moves to position with the highest Minimax value. The best achievable payoff against the best play. Two playing game. Just to take a simple two playing game. One is it's a starting position. It's the initial state. The initial state to you are travel to the initial state to one by one to the minimum state and maximum state. Finally, you can go to reach the destinations. Minimax strategy. Why do we take the minimum value every other leaf of the tree? These nodes represent an opponent choice of move. The computer assumes that the human will choose that move that least value to the computer. A minimax strategy, just you have a choose the minimum value you can travel to the source to the initial state to end state. Take a simple example. I want to travel from here one location to any another location. Mean the initial state is the starting position, starting location. Then travel to the one by one. Then calculate the distance. If the distance is the minimum value, means just you can travel and finally you can go to reach the destination within a shortest period with the minimum cost value. So you can find the minimum cost value with the source place to otherwise initial state to final state. So take a simple example explained minimax strategy. Why do we take a minimum value every other leaf level of the tree? Because we are in this question we are going to answer that because you can choose the minimum cost value, then only can easily to travel from a source place to destination, otherwise one sequence to any another sequence. So you can choose the minimum cost value. These nodes represent the opponent choice to move. The computer assumes that the human will choose that move that least value to the computer. A minimax, let's take a simple example, minimax algorithm. Function minimax decision written as an action. You maximum value state, return action is the successor. Okay, then move to the function maximum value, return to the utility value, terminal state to the utility state one by one. You can travel from a source place to next nearest path with the maximum value, otherwise minimum value. You have two functions. One is the maximum value function and another one is the minimum value function. You can travel from a source to destination, maximum value function and the minimum value function, and return to the maximum or minimum. If you are traveling to the maximum value function, finally you can reach the destination. Take a cost is high. If you are traveling the function of minimum value, means you are traveling the minimum time to travel, and finally you can go to reach the destination. It's called the minimax algorithm. The minimax is done depth first. Okay, maximum, then you're traveling to the minimum one by one. Finally, you can go to travel to the reach the destination place, otherwise leaf node place. You're traveling in minimax max. The final leaf node, you are traveled in the leaf node. Finally, you can reach the destination of final position. Okay, properties of minimax complete. Yes, it's a finite optimal path. Yes, it's optimal path because you can use the minimax concept used to find the shortest path between a source place to destinations. Time complexity order of PM. These are the some other important topics we are discussed in the today's sessions. Okay, I will explain once again what are the important topics we are discussing in today's session. Just first we will discuss about the what you mean by game, what the important role of the game, then application of game theory. Under the application of game theory, we can implement 3 positions. Take a simple example. One is economic models, social science, and military strategies used for the application of game theory. Definition of game. The definition of game: a game has at least 2 players to play the one software program is called as a game. It's a game based on the game theory. So just consider in the real time world, 2 players. One player is the opponent party. If you are playing, you are a player, and your opposite opponent party have another one player. In system based, system is the one player. You are playing with the system. System is the one player. You are playing with the system. It's the another one player. So at least minimum 2 players mandatory for the any game game. The game theory. What kinds of games? Then what kinds of games? So 4 important level of characteristics: sequence of move to play, rules that specific possible moves, rules that specific payment for each movement, objective of the maximum your payment. It's a game with the search problems, unpredictable opponent for the games is are predictable. 2 types of games. It's a simple flow diagram how to play the 2 players game, how to execute the sequence one by one. If you are completed the final level means game over and the end of the game. Otherwise, create a generate a successor, based on the successor, execute the operations one by one. Types of game. Under the types of game, 2 types of game. One is a deterministic game and another one is a non-deterministic game. Under the deterministic game, you have a not involving the opponent party. It's called a not involving. In non-deterministic game, opposite party is possible to involve the game. Involve the person is called as the non-deterministic. Game theory. These are the important game theorem: game, rules, perfect information, strategy, moves, and outcome payoff. These are the important. Then how to deterministic rules, that you are using a minimax algorithm used to execute the operation under the game theory and explain the concept one by one. Based on the minimax terminology, the maximum position, what do you mean by maximum position? The value of the largest successor, the minimum position value of the smallest successor. Everything that I explained with the example. Okay, these are the important topics. Then finally, we are discussing about the how to implement the concept using a minimax algorithm. In the minimax algorithm, we have 2 important functions. One is the maximum value function explained, and another one is the minimum value function also explained. Okay, these are the important topics we are discussed in the today's session about the gaming with the game theory. Next session, we are discussing about the another one important topic under the artificial intelligence. Thank you.